Bultmann and in a way blazed the trail in applying being and times categories to religious literature, and as a philosopher worked out some of the methodological aspects of demythologizing. I've recently discovered that he was the first to use the term, not Bultmann, and he, after that beginning in the Marburg of the 20s and early 30s, lived in Israel, fought in the Palestinian War of 1948, moved from there via the British Army, where I think he marched in a British uniform back into his hometown of Mönchengladbach, if I'm not mistaken. From there to Canada, and from there to New York. He is one of those figures that the tragedies of the Second World War have directly influenced, and America is the richer by the tragedy that has been part and parcel of his daily living. His paper this morning is entitled "The Meaning of the Scientific and Technological Revolution."
Ladies and gentlemen, we live in a revolution and have been living in one, we of the West, for a long time. Do length of time and revolution go together in our concepts? The revolution we have in mind concerns the world we live in, consequently the ways of our living, and finally, or perhaps first, the modes of our thinking. In brief, what is being revolutionized is human environment, behavior, and thought. Now, of revolution we speak as distinct from evolution when the changes in question, a collective change in human affairs, is violent and unsettling in character, and when it involves the very foundations of that which changes, not merely its surface. Violence is partly a matter of the mere speed of change. Even the most profound and far-reaching change, affecting all the things I named, if only slow enough, is not considered a revolution. But what is fast? What's slow? By what standard do we measure? Is not the difference between slow and fast, and thus between evolution and revolution, entirely relative, and therefore arbitrary? Relative it is, but not arbitrary, for it is relative to something itself absolute, to a natural unit of measurement, the individual human lifespan, the length of a generation. And this is a good test that anyone can make when his time comes. If a man in the fullness of his days, at the end of his life, can pass on the wisdom of his accumulated experience to those who grow up after him, if what he has learned in his youth, added to but not discarded in his maturity, still serves him in his old age, and is still worth teaching the then young, then his was not an age of revolution. The world into which his children enter is still his world, not because it is entirely unchanged, but because the changes that did occur were gradual and limited enough for him to absorb them into his initial stock and keep abreast of them. If, however, a man in his advancing years has to turn to his children or even grandchildren to tell him what is what, if his own acquired knowledge and understanding no longer avail him, if at the end of his days he finds himself to be obsolete rather than wise, then we may term the weight and scope of change that thus overtook him revolutionary. Adopting this standard, the only natural one for the finite and mortal beings that we are, it is meaningful and entirely legitimate to speak of a revolution going on through generations and even centuries. which is precisely what we do when we date the state of revolution we live in variously back to the First World War, to the Industrial Revolution, to the French Revolution, and ultimately to the rise of the new science and cosmology in the 16th and 17th centuries, with which it all began. Truly a revolution of secular proportions. To be sure, the pace of events was not always as breathtaking during those centuries as it is now, and from a certain point on we note a distinct and still growing acceleration, which becomes itself a salient fact and throws light on the nature of the entire movement. But it was revolutionary from its inception, by its intrinsic nature, and it periodically spawned new, sudden turning points of the briefer and more concentrated kind we customarily term revolution, but which in retrospect we recognize as parts, as critical phases of the one ongoing movement, which is a revolution in its entirety. But let me turn back once more to my initial statement of what characterizes revolution. I said that it concerns man's environment, behavior, and thought. One qualification is missing here. In order to be termed a revolution, the change must be man-made. It must be ultimately have its source in ourselves. We would not honor with the name of revolution a change in human affairs brought about by some cosmic event, a sudden change in climate, or anything of the kind. We must be subjects, agents of the change, however much we may also be the objects. We inevitably become the objects, of course, if the subjective change is effective, that is, if it turns into practice and thus affects the conditions of life. But if the revolution originates in man, then it originates in thought. And it may at first be a revolution of thought purely, of looking at things before it becomes one of action too, of dealing with things. This is indeed the sequence of the scientific and technological revolution to which these reflections are devoted. The scientific revolution changed man's ways of thinking by thinking before it materially changed, even affected, his ways of living. It was a change in theory, in worldview, in metaphysical outlook, in conception and method of knowledge. It did not at first, not for a long time, even contemplate the realm of practice. Modern science started with hardly any technological intent. The mere sign of this is that it started mainly as cosmology, and the cosmos does not lend itself to manipulation. Technology, historically speaking, is the delayed effect of the scientific and metaphysical revolution with which the modern age begins. The theoretical change alone would have merited the name of a revolution in its own right, even without this later revolutionizing effect. But let us not assume that this effect was accidental. The technological turn later given to the speculative revolution was somehow in the cards from the beginning. Its possibility is implied in the original conception of reality, that is, it is implied as a possibility and almost as an inescapable consequence in the metaphysics of modern science. And its eventual emergence and taking over is the almost necessary drawing of the conclusion from the intellectual premises which the scientific revolution had established. If this is the case, then the present global technology of man has itself a metaphysical side to it, besides the more obvious practical one. The meaning of the technological revolution is thus part of, indeed, the completion of the metaphysical meaning of the scientific revolution. It is the metaphysics of science come into the open. And one other remark concerning the sequence of the revolution. If it started in thought, then it started in freedom, as an exercise of human freedom. the first trailblazers of the revolution, men like Copernicus, Galileo, Descartes, and others, were a select few who came by their novel conception in acts of independent insight and personal decision, men who broke with prevailing long-established views and habits of thought, and whose feat, a feat for initiates only, was at first little noticed by the majority of their contemporaries. These innovators, then, were free and self-willed agents. They were revolutionaries. But the more this outlook became common property, the more there accrued an irresistible and irreversible compulsion to the movement which they had started. And its later protagonists were simply born into it by historical necessity, no longer entering it as a matter of decision. And when, in addition, the technological factor came into play, changing the external conditions of life, then a self-feeding necessity was set up, a necessity from outside that increasingly took possession of the movement, gathering momentum on its own, carrying its carriers along as its appointed instruments. Thus, while the revolution was started by revolutionaries, it is now continued, although still a revolution, by the orthodox. What started in acts of supreme and daring freedom has set up its own necessity and proceeds on its course like a second deterministic nature, no less deterministic for being man-made. What then were the main tenets of the scientific revolution? A revolution at first, as I said, merely of speculation. We have to cast our minds back to the 16th and 17th centuries. Now, the first thing that emerged from the first feat of this revolution, which actually made its appearance in a book that contains the word revolution in its very title, though in a very different sense, Copernicus' book De Revolutionibus Orbium Celestium, on the revolutions of the celestial orbs. I say the first really new thing that emerged from the new cosmology, beyond the obvious displacement of the Earth from the center and the other direct content of the Copernican doctrine, was the necessarily implied proposition of the homogeneity of nature as a whole. That is, the entirely new conception that nature throughout the universe is the same everywhere. Why did this follow from the Copernican revolution? That is, from the substitution of the heliocentric for the geocentric cosmology. It followed therefrom because, with one stroke, the essential difference between the celestial and terrestrial spheres, between the world of the heavens and the world of this earth, was abolished. The earth became one among the planets, a star itself, and by the same token the planets, instead of being of a nobler, more sublime type of being, became instances of the same kind of physical reality with which we are acquainted here on this crude, material, heavy earth. Thus, the Copernican revolution abolished the idea of a hierarchy in nature. Nature is not a hierarchical principle, therefore the universe is not a hierarchical order. It is uniform throughout. Now, in the first place, this uniformity means that nature consists of the same kind of material, the same substance throughout. But if it consists of the same substance, it, as witnessed by the substantial sameness of Earth and planets, then there also is a sameness of laws. The same physics applies to the heavens that applies to the earth. And the identity of these laws, which hold throughout the universe, turned out in due course to be the identity of the laws of mechanics. Another implication was that the universe is infinite. This not as an assertion of positive fact, for, of course, infinity is not ascertainable, but as a negative statement, namely, the realization that there is no intrinsic reason in the given order of things for setting a limit anywhere to the shape of things. That is, there is no privileged limiting form that would dictate the conception of the universe as a self-contained, enclosed, finite entity in accordance with that form, such as the spherical form of the classical and medieval universe. In former terms, the very requirement of perfection, as also the religious requirement that the created has to be finite as distinct from the infinity of God, had made it axiomatic that the universe must be finite and closed and exhibit a definite form. The new universe was open-ended, with no determinate shape or form, therefore not exhibiting a defined structure, no particular architecture to which it is bound. Therefore, it also is open with respect to what is possible within it, to what can be where and when. Anything can be anywhere and anytime. If this is so, we have the space of the new universe. If we have this space of the new universe, homogeneous space stretching in all directions, a neutral space, then there are no longer distinguished or preferred places and directions in the universe. The place of everything is, metaphysically speaking, accidental. The place of the earth within the total scheme of things is not distinguished by any particular qualities from any other place. The directions up and down have lost their absolute meaning. The particular levels in the form of vertical structuring of things, the ascending order, according to which the nobler parts of substance tend upward, the heavier, cruder parts tend downward, this whole directional order of things is abolished. This in part repeats what I have said before about the disappearance of a natural hierarchy, but it means in this context that there remains no distinction of directions and places in the neutral extension of cosmic space. This one substance of nature, defined as volumes in space, as bodies distributed through the breadth and depth of the geometrical receptacle of pure extension, this substance is characterized by one prominent feature, which becomes more and more the subject matter of all scientific endeavor, and that is measurability. The one aspect of reality which lends itself to strict determination is magnitude, its quantitative aspect. What is measurable in nature enters into the grasp of science. Therefore, changes in nature, which means shifts of space relations in time, are characterized by their calculability. All changes, if they are conceived in quantitative terms and as subject to certain constants, are calculable. It is the calculable aspect of what happens in nature which becomes the sole object of scientific analysis. Therefore, mathematics becomes the universal instrument of scientific knowledge, the universal mode of cognition. And the idea of a mathematical physics is born with the very conception of this neutral, quantitative, extensive world stuff that constitutes reality essentially. Now, the sameness of the laws which govern this wide spread of bodies through space, the sameness of the laws that govern their changes, means that one set of laws is sufficient for all phenomena, that there are not different orders or classes of things calling for the application of different types of laws, and thus for different modes of knowledge. The reduction of every type of phenomenal change to one basic set of laws means, of course, reduction to those laws which govern the basic level of reality, namely pure matter distributed in space, bodies interacting according to their geometrical configuration. These laws are the laws of mechanics. It was Newton who drew the final consequence from the original conception of his predecessors, when he applied the analysis of motions into their single dynamic factors that operate according to fixed constants, when he applied this analysis to the interpretation of all phenomena, terrestrial or celestial. No difference anymore. That is, The mechanics of the heavens is the same as the mechanics of bodies under our immediate survey and our experimental control. Thus the idea of the world machine arises. The world is one great mechanism. Now, calculability implies certain negative conceptions together with the positive ones. The positive I mentioned, namely the holding of one set of laws that operate according to fixed constants, and the strict measurability of their actions and of the entities involved in them. Of the negative aspects, I mentioned before the discarding of the idea of a hierarchical order. But there is more involved of negative aspects in the idea of a mechanistic nature. For one thing, we have the exclusion of teleology. Nature is not a place, the new nature, or the nature of the new science, is not a place where we can look for ends or goals. Nature does not act according to any preferences, values, or set ends. Only efficient courses are left. The whole system of final courses, that for the sake of which something happens, is extruded from the science of nature. In other words, the whole Aristotelian and medieval scheme of explaining things. Now, the exclusion of final courses from the conceptual scheme of natural knowledge, the denial of ends or aims to any process outside man, means that nature is indifferent to all distinctions of value. It is even indifferent to what it achieves itself by its own processes. Nature cannot be thwarted because it has nothing to achieve. It only proceeds, and these processes are automatic. Nature operates from necessity. But again, this is not a necessity imposed on it, on nature, not a necessity of superior force or compulsion, but the mere necessity of there being just one type of interconnection of things and no alternative that may interfere with that operation of uniform laws. That is to say, the object of human knowledge, the whole ceaseless drama of creation, be it the universe, be it terrestrial nature, be it living nature, is divested of any will of its own. If it has no ends, if it is indifferent, then there is no analogy in nature to what man is aware of in himself, namely that outcomes do make a difference, that one direction may be preferable to another one, that certain outcomes are fulfillments, realizations, successful, while others are failures. Such differences are completely denied to the operation of nature. To say it again, the nature of modern science is something which has no will and of which it does not even make sense to attribute to it even an analogy of will, of intention, of preference, of interest, of choice. From this follows that there is nothing terminal in nature. None of the formations that make their appearance in the ongoing transactions, in the interplay of forces, no formations that happen to result from them represent anything in which, as it were, a process has reached its natural, appointed terminus. There are no terminal realizations of intended effects. For example, the solar system, which Newton analyzed mechanically, does not represent, considered in the ultimate meaning of the causality involved in its genesis and its function, does not represent an achievement, a realization. What it does represent is merely the equilibrium which has worked itself out in the course of long sequences of interactions of forces. If certain initial conditions had been different from the ones that were, we would have a different solar system, or none at all. And the overall system of nature as an equilibrium system of forces would not be the worse for that in any way, except that we would not be here. There is, in the existence of the solar system as distinct from any other, in the distance of the particular planet Earth from its sun, in the particular shape of its orbit, of the ecliptic, and so on, of all the cosmic dispositions that make life possible on Earth, nothing providential. There is nothing we may say nature has any reason to be proud of, and we have any reason to admire or to be thankful for. It so happened that the conditions gave rise, among all the infinite possibilities there were, to the emergence of this one. Now, this fact that all formations in nature are in a certain sense accidental, though they are necessary in causal terms, the fact that there is nothing terminal and therefore nothing purposive in any of the emergent forms of nature applies also to the life forms and even to man. What holds for the structures and entities of inanimate nature, which are the consequence of a history of mechanics that goes on beyond them to other and other configurations of matter, that is the simple fact that any given configuration is nothing but a point of passage to another and another and another one, and does not represent a terminal realization of an idea of nature, this principle or view was extended by Darwinism to the sphere of the living world. In the living world, too, a certain mechanics operates whose effects astound us, among whose effects we are ourselves, we who harbor purpose, intention, preference, love and hate, joy and grief. But that which brought this about, us and all the other living creatures, is not affected in the least by any of these feelings, nor motivated by any inner direction toward them. It so happens that in the combination of chance variation or random mutation on the one hand, and natural selection on the other hand, there emerge forms upon forms, and the fact that man is among them is a mere oddity. Speaking cosmically, speaking in terms of mere natural categories, there is nothing in nature conceived as a great automaton of indifferent forces which would have chosen, as it were, to take this route. Now, that which has no will and no preference, that which is indifferent to itself, this nature solicits no respect and reverence. More and more, the relation of piety and awe towards nature, of that reverence which sees and admires divine wisdom in the order of things, vanishes with the success of the analysis of all natural things into their elementary conditions and factors. Since their elementary conditions and factors are the same throughout, and in a way marked by a certain stupidity of operation, by that monotonous sameness of a few rules which the laws of mechanics can so easily describe, or so it seemed at least until quite recently, it follows that the more the successes of physical analysis brought nature into the grasp of human knowledge, the less it could still remain an object of human reverence. If there is nothing terminal in nature, nothing that fulfills nature's own intention, then anything can be done with nature by using its own laws. Nature is subject to man's manipulation. He does not violate any intrinsic integrity of nature, whatever he does, because there is no such law of integrity in a nature conceived in the terms of natural science. That is, nature conceived as its own perpetual accident, in which each thing could as well be otherwise without being any the less natural. If nature is mere object, in no sense subject, if it is devoid of will, then man remains as the sole subject and the sole will, except for a divine subject and a divine will when they are still believed in. But with this, science and natural philosophy have nothing to do. Within its own terms, as now understood, the world, after first having become the object of man's knowledge, becomes the object of his will. And his knowledge is put in the service of his will. And the will, of course, is a will for power over things. The heavens no longer declare the glory of God, but the materials of nature are ready for the use of man. This is one train of reasoning that shows how the scientific revolution was intrinsically ready, fit for the technological turn which was given to it later. There are other lines of reasoning which lead to the same result. I mentioned two, namely the role of analysis and that of experiment. The analysis of any complex phenomenon into its simplest geometrical, material, and dynamical factors amounts to finding out how even the most sophisticated natural entity is brought about in terms of the primitive components. Now, to know how a thing is made up of its primitive elements leads of itself to knowing how one can make it up oneself out of those elements. The transition from analytical knowledge to making, that is, to providing the primary data and manipulating them so as to secure the desired results, the passage from the analytic knowledge to the synthetic operation is a natural one. And the passage, again, from experiment as a means of knowledge to applied science as a means of use is obvious. Practice in the service of theory is easily reversed into theory in the service of practice. And it is distinctive of the modern natural science that it is not a merely contemplative one to begin with, but gains its knowledge by doing certain things to nature, by, in a small way, effecting changes in a planned way. Though this is done originally for the sake of knowledge and not for the sake of any practical use, it can be easily turned around so that, as I said before, practice in the service of theory, namely experimental practice, is easily reversed into theory put to the service of human practice. Nevertheless, technology, it turned out in the paradoxical course of actual history, was not drawn as a logical consequence at any large scale from the new scientific conception of the world right away. Not even for almost 2 centuries was the obvious conclusion drawn in practice. In other words, technology emerged as a delayed effect of the scientific revolution and did not accompany it from the beginning. Before passing to this strictly technological aspect of the revolution, the second part of my theme, let me say a few words about how man reacted to the new vista of the universe before the question of a practical application arose in earnest. As I said before, the change was at first a theoretical, speculative one. And very soon after Copernicus, thinkers began to realize that something tremendous had happened, something that profoundly changed the human condition. And this was realized by thinkers who themselves had no hand in the process by which modern science arose. I remind you briefly of 3: Giordano Bruno, Blaise Pascal, Francis Bacon. Bruno was the first to realize, a generation after Copernicus, to realize fully what the breakdown of the closed medieval universe meant. It's interesting to note that he enthusiastically, exuberantly, religiously hailed the throwing open, this breaching of all the boundaries of the finite spherical world, and the vanishing of the hierarchical order, the opening up of infinite space. He greets it, he hails it as a triumphal liberation of the human spirit. He speaks as if of prison walls that have fallen down, and men can not only face infinity as his own world, but his spirit can soar into these infinite spaces. To him, the infinity of space, through which are scattered worlds upon worlds, where each of the shining stars is another sun, presumably with its own planets, to him this cosmic infinity was the direct manifestation of the infinite creativity of God. And you see how an entirely new argument enters here upon the dialectical stage. In the Middle Ages, the argument was, infinity belongs to God. What is created must be finite. There is a radical difference between the divine and the natural, and one of the differences is that the natural, as being created, is finite, therefore limited in size and force, thus no infinite world. To Giordano Bruno, whose God is not the transcendental creator of traditional theology, but an immanent principle, pantheistic conception, the world as the direct expression of divine reality, not as something created by God, but as the direct expression of divine reality, must be infinite if God is infinite. If divine power is infinite, then the universe is infinite. And so the spatial infinity, which has now come to light by the new astronomy, is a truer revelation of the divine than all the previous conceptions of the world, which were conceived partly in the awe of a transcendental deity. But against this enthusiasm with which Bruno hailed the new world, and which was so positive because Bruno was a pantheist, so that in this endless matter throughout space he saw more than matter, and in this space more than merely the empty place for more and more of the same, dead material, seeing in them animated expressions of divine reality, I say this same infinity, which so inspired Bruno, inspired another thinker in the following century with a sense of terror. And here I speak of Pascal. He was the first to shrink from the immensity of an alien universe into the loneliness of an abandoned self. You are probably familiar with the famous passage from the Pensées of Pascal, cast into the infinite immensity of spaces of which I am ignorant and which know me not, I am frightened. Incidentally, he doesn't speak so much in his own name, but in the name of the free thinker whose condition he contemplates, he imaginatively expresses. Which know me not is a crucial phrase here. More than the quantitative disproportion, the insignificance of man as a magnitude in this vastness, it is the silence, that is the indifference of this universe to human aspirations, which constitutes the utter loneliness of man in the new scheme of things. Now here you have two quite opposite reactions to the appearance of the new image of nature and the universe. The enthusiastic greeting of the open infinity, the terror of lonely man vis-à-vis a nature which was essentially alien to him. This alienness of nature became more and more a persuasive fact. Alien, however, does here not mean hostile. A hostile world is not entirely alien, because hostility contains something we can understand, we can communicate with, even if we have to fight it. The universe in which man increasingly found himself as modern science progressed is alien to him because it is entirely indifferent to whatever is of interest to man. All the categories by which man orders, evaluates, determines his own being have no application whatsoever to this nature and have no origin in it, are not derivable from anything in nature, are not sanctioned by it, do not fit into it. Now, this alienness of nature, which according to the different temperaments may inspire different attitudes in man, has among the different possibilities also this, that it encourages, nay, invites man to the relation of straightforward utility and power with respect to his natural environment. And this possibility, or this attitude towards nature, was also realized early in a speculative way by one of the pioneer thinkers of the New Age, namely Bacon, a contemporary of Bruno and of Galileo, prior to Pascal, a man of Elizabeth in England, who had the vision that the new knowledge of nature put the means into the hands of man to make himself master of his natural environment. The theme of a new mastery of man over nature is sounded at the beginning, though it is sounded by one who was not too familiar with the mathematical and mechanical procedures of his contemporary Galileo and others, and though had not really a very good basis on for making good his own postulate. It was a kind of divinatory anticipation of what was to come, when Bacon proclaimed that knowledge is power, and that the true aim and goal of knowledge is to advance the estate of men on earth, the kingdom of men. to pit man's forces more successfully against nature so as to overcome human necessity and misery. And his idea was, a very humanistic one, that man's power over nature, gained by knowledge of nature, should replace man's power over man. That when the full power over nature is gained, to which man is entitled, the abundance of the human estate would make it superfluous that man rule over man, and would even take away the motives for that. For man's rule over man is a rule for the sake of wealth, or for the sake of securing the share of one's own from the scarcity of nature, which means denying that share or the equal share to others. But if wealth and abundance of human living can be achieved by the direct utilization of the abundance of nature, in other words, if the principle of the scarcity of nature is overcome by the application of knowledge, by applied science, this would eliminate the reason for the rule of man over man, and thus naturally abolish such rule. Now, I leave it to you to check what has happened against this prophecy. And indeed, the technology which came underway in the 18th century, from the later 18th century on, and gathered momentum in the 19th century and now engulfs everything, was indeed at first operated in the service of wealth. And the first stage of modern technology reflects to some extent the development of natural science itself. Since it is mechanics which first emerged as the ruling natural science, mechanical physics, in other words, we have as the first stage in the great technological revolution the mechanical stage. The first stage of the technological revolution is represented by such invention as the steam engine, machinery made of rigid materials, solid bodies, interlocking according to mechanical principles, doing work. The steam engine is a prominent example, or the locomotive. The use of the first stage of technology, the mechanical stage, is the production of wealth and the transportation of the products. And in a certain way, the objects of this first stage of the technological revolution are rather close to nature. They are made of natural substances, and they were considered in a way to imitate the principles of nature herself. And one cannot say even that this first stage of technology is decidedly dependent on the condition of scientific physics, which had far advanced by that time beyond the relatively primitive stage of mere mechanics. Most of its apparatus, of the apparatus of the technology of the Industrial Revolution, could be, and as a matter of fact, was designed by craftsmen rather than by scientists. The engineer was not, in the original stages of modern technology, a highly scientifically trained person. He was an empiricist, highly scientifically trained person. He was an empiricist with a knowledge of substances, of matters, of certain laws of mechanics, the principle of the lever, and the transmission of motion, and the expansion of gases under the influence of heat. But no higher calculus was involved, no very complicated scientific equipment, and no sophisticated theory. The first case where science becomes itself the condition for the emergence of an industry in the technological age, and where that technology is from the beginning a function of the scientific progress itself, is a new stage of science, not mechanical science, but chemical science. The chemical industry is the first industry which really originates from scientific discoveries, And it is here in the 19th century, when the chemical industry arises, that these two things come together definitely, namely the scientific progress and the technological and industrial progress. They become one in that it is really the chemical industry which itself drives forward chemical science and vice versa. So I claim that the first real fusion between science and technology, or the beginning of the scientific age in the practical affairs of man, is with the rise of the chemical industry. Of course, within the mechanical industry, the same happens. When, instead of the steam engine, we have new sources of power, such as electrical power. It is again the case that without an advanced stage of physical science and Maxwell's equations and the work of Faraday and of Maxwell, this electrical industry could not have arisen, while the steam engine of Watts a century earlier could be constructed without Watts being much aware of the subtleties of, let us say, Laplace's astronomy and physics. But it is not the fact that the complete union and interlocking of scientific and technological activity takes place first in chemical industry is not the only distinctive mark of this stage of the technological revolution. There is an essential difference between the chemical stage and the mechanical stage of this revolution. The mechanical stage, which of course went on concurrently. In the chemical stage, man does something more than constructing machinery from natural materials and using natural forces as power sources. In chemistry, man changes the substances of nature and even comes to synthesize substances which nature has never produced. It is a deeper, a more profound, more independent role which man assumes, and a deeper meddling, as we may say, with the patterns of nature. Man becomes a designer in a very different, and a creator, we may say, and as God's substitute, in a very different sense from the way in which the engineer constructs machines. We are in an age now when substances can be made to specification, substances of which nature did not dream. Here the creative role of man, as distinct from the merely utilizing and exploitative role, comes to light. A man assumes to some extent a function which he had ascribed to the Creator, to God, namely to determine what substances there are to be, of what substances things exist, and which elements and combinations of elements will be found in nature. When the mechanical technology arose, and even when it was foreseen by such prophets like Descartes and Bacon, they liked to speak of man imitating nature. In constructing automata, in constructing machines, man imitates nature, which itself is one great mechanism. The simile of imitating nature is no longer applicable to the chemical stage of the revolution, because there it is not that man looks at how nature does it and then does it himself, but he improves. He improves on nature in all ways, serving his own ends. And after this, we have another stage of the technological revolution, which in the so-called communication industry, the electronic stage. And one may say that with each such step, the artificiality of what man creates advances a further step. We move more and more away from what can be named an imitation of nature. When Bacon envisaged man's utilizing nature for his purposes, when Descartes spoke of the machines to be constructed by men, they always liked, as I said before, to call this an imitation of nature by men. And it is the cleverness of man that observes nature properly in its own workshop, as it were, which then is able to do the same. But the farther the technological revolution advances, the farther away moves man from such an imitation of nature, and the more improbable, the more unlike nature, the more artificial and contrived do men's technological contrivances become. Let's take the case of a Telstar, a satellite, which in one sense one may say is a fulfillment of Newtonian physics. It is, we may say, practical astronomy. Astronomy, the most theoretical and contemplative of all sciences, contemplative because the stars are so immutable in their courses, becomes a practical discipline. Man himself can put celestial bodies into orbit, and therefore is himself the initiator of astronomical facts. And in that sense, he is still in the terms of what the classical beginners of the process called man imitating nature. So in that respect, a Telstar, man with a Telstar imitates nature. But then look at this body, at such a body. Of what does it consist? Its orbit and the period of revolution are the least interesting thing of it. That is the practical astronomy there. What is interesting is their instrumentation. They are instrument packages. And there is nothing in nature which even remotely foreshadows the kind of things which man now puts into orbit. Of course, the rotating bodies in space, that nature has. But this kind of instrument is something with which man has added something in the whole inventory of things in the world which has never been, which may never be again when man vanishes. It is entirely of his own making. There is perhaps in the offing another, perhaps last stage in the technological revolution. If we see which sciences have contributed to the technological revolution, then we had first mechanics, Newtonian mechanics, expressed in the machine stage of the technological revolution. Then we have chemistry, and its technological expression was the chemical industry, the plastic materials with which we are now surround our lives and so on. And then we have electronics as the expression, the practical expression of the electrical part, let us say, stage of modern physical science. But there is one great branch of natural science which seems not, or up to now, seems not to have lent itself to technological translation, and that is biology. Biology. Are we perhaps on the threshold of a technological revolution based on our biological knowledge? Certainly the possibility arose, or the prospect at least arises, with the moment when genetics supplemented the Darwinian evolutionary scheme by supplying the particular dynamics of genetics, which really made a scientific theory out of the Darwinian hypothesis. When this happened, what followed was, among other things, that we get into possession of the mechanics that determine the pattern of living things. If we have the key to the genetic code, and if we develop the technical means of manipulating that code, that is, of rewriting it, knowing an alphabet, we can, of course, also make our own combinations of the letters of that alphabet into new words and sentences, then, in principle, we might be able to make over the living world, including ourselves, including men. Knowing a code means, as I said again, not only understanding it, but also being able to write it. And here we are on the potential threshold of a technological revolution, of which I pray that it may not be made use of, a possibility, but knowing that, given a power, a possibility, man cannot resist using it, I see here much more than in the possession of the atomic bomb and similar means of catastrophically ending our career, the greatest danger of a technology which conjoins unlimited power over our own being with the absence of any knowledge what it might be used for the benefit of ourselves. In other words, faced with the possibility that we can determine the image of man by genetic manipulation, it becomes more imperative than ever that we have an image of man, or that we know by what standards to determine the most desirable image, or in other words, and now using more old-fashioned expression, that we know what is the good of man. It is quite clear that the idea of a genetic manipulation is in itself not compatible with the idea of man being created in the image of God. It seems you cannot have both. You either believe that man represents a divine intention, that he is created in the image of God, or you hold that he is one of those accidents of nature which one can, through further accidents, among which are included our own interferences, change. And then change according to desire, according to expediency, according to power interests, according to taste, according to all kind of foibles to which man himself is subject. But the critical moment which we are approaching is this, that man being exposed to changes, intended changes on his own part, must at the same time be guided by an image that is removed from the mere arbitrary choices of the moment. It is at this point where I see the meaning of the technological revolution come to a final crisis. It has been crisis while it was going on, and a crisis which sometimes was a very fertile and fruitful crisis. It begins to assume, and I see I do not play on the theme of the atomic bomb, which we have been hearing about for a long time, and rightfully, but it is, even apart from this catastrophic contingency, out of its own increase of directionless power, approaching the moment where the desideratum of a direction, of a norm, of a knowledge, or, to put it very briefly, where the possession of wisdom becomes a vital necessity for the possession of power, not to lead into utter utter danger and catastrophe.
Thank you, Professor Jonas, for this stimulating lecture, and we are dismissed.
Yes. That's fascinating.
Have you a moment for a question here, Dr. Jonas? I was interested in your statement earlier in your lecture that the cosmos does not lend itself to manipulation. And then...
The cosmos, I meant the macrocosmos.
Okay. Because then it seemed that your theme pointed out through the various phases of technological revolution, we are in fact manipulating that which is in the cosmos.
Yes, but sure, but surely, I mean, terrestrial nature has always lent itself to some manipulation. From the beginning of the, let us say, that man, let us say, of agriculture, man has changed his environment, has manipulated things, has made instruments, has tamed cattle, animals, and so on. Domesticated, and so that the cosmos does not lend itself to manipulation. I meant the astronomical. The cosmos is the astronomers depth. The stars in their courses were thought to be exempt from any possible influence, not only by man, but of any other, let's see, disturbing natural forces. Some sacred